Alright, this is side 2 of your test. Problem number 7 is a long division problem. And so let's practice going through long division. It's been a while for some of you. So we just set it up like a long division problem, a to the fourth. Now there is no cubic term, so we plug in a 0 to hold that spot. 2a squared negative, then there's no linear term, so we put in a 0a plus 4. All divided by a minus 2. Okay, so remember how we approach these things. We ask ourselves, a times what gives me 4a to the fourth, and I'd have to multiply by a 4 and an a and a cubed. And then you take the answer to that and you multiply it times the a and times the negative 2. So we distribute it out. We get 4a to the fourth minus 8a cubed. And don't forget, you subtract that line. This is where it's become helpful that I put that 0a cubed. So now I have a cubed lining up with a cubed. That 0 doesn't do anything to it. It's going to be a positive 8a cubed because I'm adding or subtracting a negative. Bring down the negative 2a squared and repeat. I'd have to take a times an 8a squared to get 8a cubed minus 16a squared. Subtract that entire line. It's going to be a 14a squared, and I bring down the 0a. Now I'm going to have to take a times a 14a. That gives me 14a squared minus 28a. Again, subtracting, so it becomes positive 28a, and I bring down the 4. Now I have to take a times a 28. Gives me 28 minus 28a minus 56. Subtract that, and I get a positive 60. So positive 60 is my remainder. I have to have a 4a cubed, an 8a squared, a 14a, a 28, and there's my positive 60 remainder over my divisor. So it is answer C. Alright, that's pretty straightforward division problem, I think. Let's erase a little bit of that. Let's go to problem B. Problem B says you have a box of a certain volume, 2x squared minus 4x minus 16, and it's a height of x minus 4, and they want you to find the base of the box, the area of the box's base. So if you think about a box here for just a second, to find its volume, it is length times width times height. Okay, so let's call this our length, this our width, and that our height. But length times width is also the area of, in this case that's the top of the box, but the top is the same as the area of the base, length times width. So essentially, volume is length times width times height, but length times width is the area of the base. So volume is area of base times height. Now in the problem, they tell me the volume, they give me that equation, they tell me the height, and they want me to find this base area. So from an equation standpoint, the area of the base would be equal to, I divide both sides by h. So volume divided by h. So I want to carry out the volume, 2x squared minus 4x minus 16 divided by height, x minus 4. You could do this with long division, but we've been practicing in class division of fractions like this. Let's just see if this thing factors. Okay. Running out of room here just a little bit. So I'll move up here. My numerator, I've got the 2, and x, and 2 times 4, and negative and positive, all over x minus 4. So I have common factors that would just cancel out. This that remains is my answer, 2x plus 4. That looks like answer C. So that's the reasoning behind that problem. Alright, let's continue on. Again, delete some of this stuff so we got a little more room. And number 9, you have to determine if this thing's odd or even. Remember, if the endpoints go the same direction, then it's going to be an even function. So we know it's even, either C or D. And then since they both go down, that indicates it's going to be a negative lead coefficient. Problem 10.
When the bell rings, Wendy Goo.
Problem 10, which of the following equations is an odd function? Not A, because it's got an even right there. And not B, because this is x to the 0 power. They just don't show it. That's even. C, if we distribute that, the rule is to add exponents. That's x to the, not 15th, but 13th. Plus x to the 9th. 13 and 9, both odd. So this is an odd function. So choose C rather, I guess. Which value A should be added to the table so it has 3 zeros? Right here, there's really only two choices, -2 or 0, because we have to hit 0 at some point. Okay. If we put the -2 in there and you think about it, this function is at 6, somewhere up here. Then it's back up here again at 2. So if I were to put a negative value in for A, it would mean that it crossed it and then came back up. That would give me 2 more zeros. See how many zeros it has right now. Right now it's got 1 0, 2 0. We want it to have 3. So I don't want to put a negative number in for A. That would give me 2 more for a total of 1, 2, 3, and 4. But by putting 0 in there, it's just going to touch it one time. Alright, that brings us to problem 12. So let's slide this up a little bit. Name all the real and imaginary zeros of this polynomial. Well, it certainly started. It's partially factored for us. I'm just going to finish up the factoring. So if I look at this first factor here, it's got a 2 inside of it as a GCF, so I can pull that out. X squared plus 4 is a sum of 2 squares, and those things are prime. We can't factor those. Now that I've pulled the 2 out, I'm going to factor the trinomial there. And so now it's in its most factored form. And the question is, what are its zeros? So what values of x make this thing equal 0? Okay, right away I can see if x is -2, this factor becomes 0, and therefore the entire product, this entire left-hand side, would become 0. So -2 is the solution. And really, what you can do is just take that factor, x plus 2, set it equal to 0, and it will tell you the solution when you solve it. This x plus 2 gives me the same solution. X squared plus 4, if I set that equal to 0 and take the 4 to the other side, I get a -4. And when I solve it by square rooting, I've got the square root of a negative number, and that's imaginary. So this one gives me, when I square root plus or minus, the square root of a negative is I, and the square root of 4 is 2. So the question is, name all the real and imaginary zeros and state their multiplicity. So -2 has a multiplicity of 2. So -2 with multiplicity of 2. Imaginary zeros, 2i with multiplicity of 2. Well, that's not my answer because I didn't get two 2i's. I got one 2i and one -2i. So now I'm looking at answer 1, -2 with multiplicity of 2, plus or minus 2i multiplicity of 1. That just means it happens one time. So A is our solution. And that is it.